Hello, students. I am Dr. Stuti Singh from ABES Engineering College and Applied Sciences and Humanities Department. So now we are going to discuss about the numericals that are based on wave optics. Okay. As in the previous lectures, you have seen in wave optics part 1, we discussed about the topics of interference. In wave optics part 2, we discussed the topics of diffraction. So now we are going to, solve or see the numericals on the topic. So today we are going to cover numericals on interference topics and numericals on diffraction topics. So we can start with the interference first. So let me write down the numerical. Okay. First numerical, white light is incident on a soap film at an angle sine inverse 4 by 5. The reflected light on examination by a spectroscope shows dark bands. Two consecutive dark bands corresponds to wavelength 6.1 into 10 to the power minus 5 centimeter and 6.0 into 10 to the power minus 5 centimeter. If mu is 4 by 3 for the film, calculate its thickness. Okay, so this is the question. White light is incident on a soap film at an angle sine inverse 4 by 5. The reflected light on examination by a spectroscope show dark bands. Two consecutive dark bands corresponds to the wavelength 6.1 and 6.0 into 10 to the power minus 5 centimeter. And if mu is 4 by 3 for the film, then calculate its thickness. So we are going to calculate the thickness. First and foremost, we should always write what is given in the numerical. So let us write down what is given in the numerical. See, over here, two lambdas are given. Okay, lambda 1 and lambda 2. Lambda 1 is 6.0 into 10 to the power minus 5 centimeter. And lambda 2 is 6.1 into 10 to the power minus 5 centimeter. Okay, and mu is given 4 by 3. Sine I is also given 4 by 5. And the question is talking about the dark bands. So what we will be considering, let n and n plus 1 are the orders of consecutive dark bands. And what is the condition of dark bands? The condition of dark bands is very good. 2 mu t cos r is equals to n lambda. Okay. So there are two equations that will be forming. One will be this equation only. Just I have to write down lambda 1. And then the other will be 2 mu t cos r is equals to n plus 1 lambda 2. Okay. So when we solve this for the value of n, what we get from equation 1 and 2, we get n is equals to lambda 2 upon lambda 1 minus lambda 2. So now substituting this value of n, substituting value of n in equation 1. In equation 1, what we get? We get 2 mu t cos r is equals to lambda 1, lambda 2 upon lambda 1 minus lambda 2. This is equation number 3. Okay. And what now? Let us calculate the value of cos r. What is the value of cos r? Cos r will be equals to under root 1 minus sine square r. And from here we can write under root 1 minus sine I by mu from Snell's law. Okay, this we can write it from Snell's law square. So when we solve this, under root 1 minus 4 by 5 upon 4 by 3 square, what we get answer is 4 by 5. Okay, so we got the value of cos r as 4 by 5. Now we can put the value of cos r. And finally, what we have to calculate? We have to calculate the thickness. So let all the equation turn into thickness. So T is equals to what? T is equals to lambda 1, lambda 2 upon lambda 1 minus lambda 2, 1 upon 2 mu cos r. Okay, substitute all the values. That is 6.1 into 10 to the power minus 5 into 6.0 10 to the power minus 5 into 3 into 5, right? We will put the value of cos r and mu, and over here we'll be getting 4 into 4. Okay, and what is, then we can also get 2 into lambda 1 minus lambda 2 is how much? From here only we can calculate it as 0.1 into 10 to the power minus 5, right? So this is the value of what? Lambda 1 minus lambda 2 is 0.1 into 10 to the power minus 5. Okay. So we are getting, when we solve this, what we get the thickness as 0.0017 centimeter. After solving, we are getting the answer as T. Okay, let us make a small change over here. Let us consider lambda 1. Lambda 1 equals to 6.1 and lambda 2 equals to 6.0. Okay, then the value of lambda 1 minus lambda 2 will be, oh, right. Okay, so now it is okay. So this is a small change that we are doing. Now let us see the another numerical on interference. Okay, now let us see the another numerical. Now let us take the numerical on the fringe width. So let us write down the question first. Question is light of wavelength 6000 angstrom falls normally on a thin wedge-shaped film of refractive index mu, that is 1.42, and refractive index 1.4, not 1.42, but 1.4. And forming fringes that are 2 mm apart. Find the angle of wedge in seconds. Okay, so again, as usual, first we will be writing the what is given in the equation, what is given in the question of the numerical, and then we will be solving. So what is given is, if we solve, lambda is given 6000 angstrom. Okay, mu is given 1.4 and omega is given 2 mm. So what is the formula for the fringe width? Omega is equals to lambda upon 2 mu theta, or theta is equals to lambda upon 2 mu omega. So we will be substituting all the values for from the numerical. So when we substitute the value, what we get? Theta is equals to 6000 into 10 to the power minus 8 upon 2 into 1.4 into 0.02 centimeter. So we have converted all the things. So when we solve this, what we get is, very right, 10.71 into 10 to the power 10 to the power minus 5 radian. But the question is asking in seconds. So what we will do is, theta is equals to 10.71 into 10 to the power minus 5 into 180 degree by pi. That is, when we solve this, this will give you the answer in the degree. And when we will put this degree 0.0061 into 60, then we will be getting the answer in the seconds. So it is 20.196 seconds, or nearly theta is equals to 22 seconds. So this is the answer for this numerical. And this is the manner also of solving this numerical, 22 seconds, right? So now we will be solving one more numerical, that is on Newton's ring. So let us write down the question first. Newton's rings are observed normally in the reflected light. Normally in the reflected light of wavelength 6000 angstrom. The diameter of the 10th dark ring is 0.50 centimeter. Find the radius of curvature of the lens and the thickness of the film. Okay, so let us solve this. So again, let us read the question carefully. What is the question? The question is, Newton's rings are observed normally in the reflected light of wavelength 6000 angstrom. The diameter of the 10th dark ring is 0.50. So let us write, and we have to find the radius, what is given in the question, radius of curvature and thickness. Okay. So let lambda is equals to 6000 angstrom. Okay. That n is equals to 10. D, the diameter of the 10th dark ring is given. So the diameter of the 10th dark ring is given as 0.50 centimeter. Okay, so we will convert this lambda also in centimeter, that is 6000 into 10 to the power minus 8 centimeter. Now let us see which formula we have to use. We have to use the formula T is equals to R square upon 2R. That is equals to D square upon this radius diameter. It will be 8 into R. Okay, the square of the diameter. So we put the value, then T will be equals to 0.5 upon 8 into 10 to the power, sorry, 0.5, just 1 minute, students. This we need also the R value, and in the numerical also we have to find out the value of R. So let us calculate the value of R. What will be R equals to, as dn square is equals to 4n lambda R. Okay, from the dark ring we know that. Then what is R equals to dn square upon 4n lambda. So when we substitute the value, what we get, 0.5 upon 4 into 10 into 6,000 into 10 to the power minus 8. After solving this, we get 10.4, or no, not 10.4, 104 point, I'll take 104.166. Okay. Now this value of R can be substituted to find out the value of T. So what is the value of T? 0.5 upon 8 into R is 104.166. So after solving, what we get? We get 3 into 10 to the power minus 4 centimeter. Okay, so in this manner, we can calculate both thickness and the R in the numerical. So we are going to start with a diffraction numerical. Okay, so let me write the question. Let us discuss. Okay, this one. Diffraction pattern of a single slit of width 0.5 centimeter is found by a lens of focal length 40 centimeter. Calculate the distance between first dark and next bright fringe. From the excess. Given wavelength four eight nine zero angstrom. Okay. So now let us see what is given in the question for solving. Okay, we should always discuss what is given in the question. So what is given in the question? F is equals to 40 centimeter. A is equals to 0.5 centimeter. Lambda is equals to 4890 into 10 to the power minus 8 centimeter. Okay. Now if we we are able to draw a screen, and from the axis, suppose O is the axis, and this is the screen. So at suppose theta 1 angle, what is forming is minima. First dark band is forming here, and from the from the axis to, and which angle it is making? Theta 1 angle. And how much is the distance from the center? Y1. And at theta 2 angle, first bright fringe is formed. Okay. So yeah, at theta 2 angle, first bright fringe is formed. So this is bright and this is dark. Sorry, this is dark and this is center. And how much is the distance? This is y2. So now let us, and what is the focal length? F is the focal length. So we can easily calculate the, what they are asking is to calculate the distance. So what we have to calculate? Y1 and Y2 we have to calculate. Okay, so let us now consider the minima equation first. So what is the minima equation? A sine theta is equals to theta 1 is equals to n lambda. Over here we are going to take n as 1. So because first order, first dark band we are talking about. So what we can write is A sine theta is equals to lambda. So what is sine theta 1 from here equals to y1 by f. From how we are writing this? We are now writing this with the help of this diagram. What is sine theta 1 equals to y1 by f. Okay. And here, then if we substitute, we see that sine theta 1 from the above equation is lambda by a. So if we equate the two, what is it? Lambda upon a is equals to y1 by f. Okay. And what is that equals to? Y1 is equals to f lambda upon a. And if we calculate, putting the value 5890 into 10 to the power minus 5, okay, minus 8 into 0.4 upon 0.5. So what we are going to get? We are going to get the value as 3.912 into 10 to the power minus 5 centimeter as y1. So one value we are now getting. Let us now calculate. This was for first dark band. Now let us calculate for the bright. So for bright, we are going to use A sine theta 2 is equals to 2n plus 1 by 2 lambda. N ki value is 1. So as n is 1, what this will become? A sine theta 2 is equals to 3 lambda by 2. Or sine theta 2 is equals to 3 lambda by 2a. Fine. And again from the diagram, what is sine theta 2 equals to? F upon y2. So from the diagram, it is sine theta 2 is equals to f upon y2. Again, we can equate the two. I'll just solve it here only for the dark band. Again, if we equate the two, what will happen? Y2 is equals to 3 lambda f upon 2a. And after substituting the values of 3 into 890 into 10 to the power to 0.4 upon 2 into 5 into 10 to the power minus 3. Then what we are going to get the answer after solving 5.860 into 10 to the power minus 5. Okay, we are now solving it in meter. Fine, and this also if we want to convert it in this also answer we are getting in meter. I've written this answer in meter. So then what we have to do is then we have to put this as, because yes, I solved it in meter. So now let me correct it. Then I have to put it this in this manner and this value also in 5 into 10 to the power minus 3. So now both the answers are in meter because I calculated this in meter. We converted this also in the meter. So both the answers are in meter. And if we calculate the difference between the two, so what is the difference between the two? If I calculate here itself, what is the difference between the two? Y2 minus Y1 is equals to 1.956 into 10 to the power minus 5 meter. This is the answer of Y2 minus Y1. Okay. Now let us solve another question. Okay, let us do another question now. Find the angular separation of 5048 angstrom and 5016 angstrom wavelength in second order. Spectrum obtained by a plane diffraction grating of grating of 15,000 lines per inch. So let us solve now this question. Okay, so how we are going to solve this? What is first and foremost, what is given? See, two lambdas are given. Okay, lambda 1 and lambda 2. So lambda 1 and lambda 2. Lambda 1 is 5048 angstrom and lambda 2 is 5016 angstrom. And what else is given? A plus B is given because it is 15,000 line per inch. So how we will calculate A plus B? A plus B is equals to 2.54 upon 15,000. So what is this equals to? 1.69 into 10 to the power minus 4. Okay, centimeter. So now what we have to calculate is angular separation. Angular means d theta is to be calculated. Let us calculate d lambda. What is d lambda? Lambda 1 minus lambda 2. So what is lambda 1 minus lambda 2? 1048 minus, 5048 minus 5016. So what is it equals to? This is equals to 32 into 10 to the power minus 8 in centimeter. Okay, so now we are calculating in centimeter. And what is the formula of d theta upon d lambda? Very right, it is n upon a plus b. And which order they are asking? They are asking for second order. So 2 into 32 into 10 to the power minus 8. N ki value is 2. 1.69 into 10 to the power minus 4. So when we solve it, what we get is 3.78 into 10 to the power minus 4 radian. So this is the value of d. This is the value of d theta. D theta is equals to, okay, because d theta is equals to n d lambda upon a plus b. Okay, so we have substituted all the values and we are getting this answer of d theta. Let us do one more numerical. Question: can D1 and D2 lines of Na, sodium, light be resolved for lambda D1 equals to 5890 angstrom and lambda D2 equals to 5896 angstrom in second order. Number of lines in grating of two grating of 2.0 centimeter wide, that is equals to 4500. So again, let us see how we are going to solve this, how we are going to solve this numerical. Okay, so let me just so let us write down what is given in the question. Lambda is equals to, so there are two lambda d1 and lambda d2. So what lambda we will be calculating, because it is being can the light be resolved? So this is the question of resolving power. That light, unlike the last one, it was of dispersive power. So lambda, if we have to calculate, we have to take the average of the both. So what will be the average? The average will be 5893 angstrom. Okay, and what will be the difference between the two? It is very clear and visible from here, from the numbers itself, that 5890, the difference is 6 angstrom. So now what we are going to do is, first we are going to calculate the lambda upon d lambda. What is the value n into n? So what is lambda upon d lambda? Lambda value we have calculated 5893 upon 6. That is 2 into n. Second order we are talking about. So what we are going calculating from here, we can calculate number of lines that are there. So it is 5893 by 12. That is nearly 491.82, or nearly n is equals to 491. And how? And as 491 n, it is less than 4500, that is provided. So lines can be resolved in second order. Okay. So see, we also did the numerical on dispersive, we did the numerical on resolving power, on fringe width, of grating. Similarly, you can solve more questions and practice good numericals for the unit. Thank you, students.